We're going on now to topic 3 of chapter 4. Now this is a section that is now included in the Math 105. We didn't cover this in Math 100. And we're dealing with intersections, unions, and compound inequalities. And we'll be talking about interval notation and domain as well. So we're going to look at a Venn diagram here a little bit. Now, what is intersection of sets and conjunctions of sentences? Well, first of all, we indicate intersection when we have, let's say, an A set and a B set, and some of the members of the A set are also found in the B set, and vice versa. So the symbol for this is sort of an upside down U, and this is red. A intersects with B. And in mathematics, the word that we use for intersection is the word AND, and. So let's see if we can set this up then as an example of intersection. And the technique is to start going through and see what letters are found in both sets. So A is found in both sets. B isn't, C isn't, D isn't, E is, F isn't, and G isn't. So the only members then that would be an intersection between these two are A and E. And we write it in roster notation. When two or more sentences are joined by the word and, there's our key word for intersection. To make a compound sentence, the new sentence is called a conjunction of the sentences. So we read it this way. -1 is less than x, and, indicating intersection, x is less than 3. Now notice that -1 is not included in the set, and 3 is not included in the set. And they're going to show us some information about this, that if we were to graph this on a number line, notice that -1 is less than x. If you read it this way, x is greater than -1. And that's what you see illustrated by this number line. And this one, and this is set builder notation, by the way, you may recall, x is less than 3. So again, a parenthesis indicating that in this case 3, and in this case here a -1 not included in the set. So if you were to take these two lines and merge them together, the area of intersection would be right here, as we see. If I make this line a little darker right in there. And notice you're putting parentheses on either end. Okay, so this is conjunction. Now here they're asking us to solve and graph. So that's what we'll do. Solve and graph. So for this first one, and we've gone over some of the techniques, 2x is greater or equal to, I'm now going to transpose this positive 1 to the other side. That makes it a negative 4 over there, because the positive 1 on this side becomes a negative 1. And I'm going to divide both sides by 2. So x is greater or equal to negative 2. And here, this one will be, we're going to divide both sides by 3. We're going to get x is less than 4. We're now going to make a number line. And the numbers we're interested in are a negative 2. So let's put the negative 2 over there. And a 4. Put the 4 right over there. Now the symbol we're using here, we're saying x is greater or equal to, we're going to use a bracket. And the word and indicates intersection. And then now x is less than 4. So here we're going to use a parenthesis. So this is where they would intersect and are conjunction. And the way we would finally write this is that negative 2 is less than or equal to x. X is less than 4. And to put that in set builder notation, we would just put our x there. And this is read x is such that, and then you would read this. In interval notation, once again, it would be from negative 2, comma 4, and on the 4 we have a parenthesis. So there they are solving it. There is the graph. And there is a way to write this conjunction. And we can also solve this together here. Again, we would subtract 1 from each term. And we can do it in 2 parts. I guess that's what they're showing us here. Okay. So the word and corresponds to intersection, and we use this upside down U. Any solution of the conjunction must make each part of the conjunction true. That is, if you graph them where they would overlap, that is, intersect. Now, sometimes there is no way to solve both parts of a conjunction at once. So here we see set A and set B do not intersect. So what is their intersection? Well, it's a empty set or a null set, or there is no set. And when this happens, that they are not connected, this is said to be a disjunction. That is, they are disjointed, a disjoint. So let's do this one. So here we're going to go x is greater than, and we transpose the 5, becomes a negative 5. Negative 5 and 10 is a positive 5. And remember, this is intersection. And we go x, transpose that, is less than. This on this side becomes a positive 4. So this is 1. And now we will graph it. Well, the numbers that we're interested in are a 5 over here and a 1 over here. So we're saying that x is less than 1. So this is going to go this way, and the arrow is that way. And we're saying here that x is greater than 5. So a parenthesis this way. And we see there is no intersection, that they are disjointed. And there we go, and there we go. Okay. Now, we're going into, and let's just go back one. Okay, I think we covered that. The union now of sets and disjunction of sentences. Now, the union of sets is that set A and set B, even though there are some in common, but because of union, and the key word for union I'm sure they're going to introduce shortly is or. The way and is for intersection, or is for union. The union of sets A and B include now all the elements. So if we were to write the union, and we only write them once actually, and we would just put them in some sort of brace here, we need an A, B, C, D. Notice E is repeated as well as A. We only write it once. And then that would be the union of these two sets where all the elements are included. When two or more sentences are joined by the word or to make a compound sentence, the new sentence is called a disjunction of the sentences. So here this is or. So let's graph it. So there's our number line. We're interested in 2. We're interested in 8. And this is x is less than 2. And x is greater than 8. Now, normally, if this were an intersection, there would be no intersection. It would be an empty set. But since this is a union, how would we write this? Well, we would write it as in interval notation that it's coming from negative infinity over here, over there, up to 2. And then we put the union sign to indicate we're joining that with the parenthesis of 8 there, up to positive infinity. Okay, that's basically how I would write it. Let's see how they're going to do it. I probably should have looked at it first here. Okay. And notice these are the two sentences, and you put them together. Since they don't connect all the way, it's a disjunction, but it is a union because they do go together. So in set builder notation, this is how you would write it. Okay? Or you could put, instead of the symbol for union, you could put the word or. Or and this symbol are the same. And that's what they're showing you here. Okay, so let's solve and graph this as we did before. Now this is going to be 2x is greater or equal. Transpose that becomes a -1 and a +3. Give me a 2. Divide both sides by 2. X is greater or equal to 1. Here we're simply going to divide both sides by 3. And we get x is less than a -1. You might recall that if we had to divide by a negative, we don't have to do it here. We would have to reverse the direction of our inequality sign to keep it true. Now let's graph it. The number we're interested in is a 1, which is over here, and a -1, which is over there. And about this one, it says x is greater or equal to 1. So we're going to use a bracket to include number 1. And our arrow goes this way. And here x is less than or equal. So this would be a parenthesis since -1 is not included in the set. And it would go this way. And this would be an OR statement. So in interval notation, from -infinity up to -1, parenthesis, union, bracket, 1, comma, infinity. Remember, infinity is always with a parenthesis. And there it is. Notice the parenthesis indicates the -1's not included. The bracket, that +1, is included. And since it's an OR, this is a disjunction. And we're now going to take a look at interval notation and domains. Okay, this gets to be a little tricky, so watch it carefully. Well, we said as far as the numerator is concerned, if things are only in the numerator, the domain of x is all real numbers. But if there's an x in the denominator, we have to equate that to 0. And then we realize that x cannot be a +7, which is what they're showing us here, because that would make our denominator undefined. So when we write that in set builder notation, we did this before, we say x is such that x is a real number and x cannot equal 7. When we graph it up to 7, but at 7 we have to put a hollow indicating that 7 is not in the set, and then the arrow continues. And then in interval notation, it would look like this. From -infinity to 7, and then a parenthesis, indicating that 7 is not in the set. And then starting at the other side of 7, again a parenthesis, going to +infinity. This is an excellent slide. I like what they've done here. Okay, now what they're doing is they're doing the domain of the sum, the difference, or the product of the functions f and g, is the intersection of the domains of f and g. So you can read this again, but we'll give you some examples. Oh, I guess that was the end. So I guess our examples are going to be in the additional exercises that I've posted in other videos on this site.